All right, guys, in this video, I'm going to talk about the nature of the roots of a quadratic function. So the roots of a quadratic are given by the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. This b squared minus 4ac, this part of it right here, is what determines for us the nature of the roots. And it's given a particular name. It's called the discriminant. So this is called the discriminant. Oops, it's a little large. Let me make that a little smaller. Too small. There we go. So this is the discriminant right here. It's this part of the quadratic formula, b squared minus 4ac. So up here I have three pictures of three graphs of potential quadratic functions. And in the first one, here on the left, I see that the graph comes down and it cuts the x-axis in two places. If the graph comes down and cuts the x-axis in two places, crosses the x-axis and then turns around and crosses it again, what that means is that the discriminant, b squared minus 4ac, the discriminant part of your quadratic function is positive. So that is, in this case, b squared minus 4ac is greater than 0 in that case, right here. Right there. If the function, the graph of the function comes down and just touches the x-axis and then turns around, like here, it doesn't cross the x-axis, it just touches it. Well then, in that case, the discriminant is equal to 0. In this case, the discriminant is equal to 0. And then over here on the right, we have the last case. If our graph comes down and then turns around before it reaches the x-axis. In this case, our function will never cross the x-axis. And what that means is that the discriminant is less than 0. It is negative. In that case right there. All right, so these are the various scenarios that you can have. All right, let's tackle a problem, and we can see how we can use the discriminant, and we can use this information then to solve some problems. All right, so this question asks us, for what value of k does the given function f of x have equal roots, where f of x is equal to x squared minus x times 2k plus 2 plus 5k plus 1. By equal roots, they mean that the graph comes down and just touches the x-axis and once and then moves away. So we have a repeating root, if you will, or equal roots. And so in that case, as we have seen, b squared minus 4ac, the discriminant will be equal to 0. And so this function will have equal roots for values of k for which b squared minus 4ac, the discriminant is equal to 0. So what we're going to do is we want to find a, b, and c, the coefficients on our x squared, our x term, and our constant. We want to then find b squared minus 4ac, our discriminant, and let that discriminant equal to 0, and then solve for k. All right, so we want to let b squared minus 4ac equal to 0, and then solve. That is what we are going to try and do here. So in that, the first thing we want to do is find a, b, and c, the coefficients. So our a value, the coefficient on our x squared term, well, I can see that that here is 1. I have 1x squared. So our a value is 1. My b value is the coefficient on my x term. I need to be careful here. I can see that here is my x term right here. I have a 2k plus 2 on my x, but I have a minus out in front. And so the coefficient on my x term is minus 2k plus 2. So it is negative 2k plus 2, which I could write as, I can distribute in my negative into my parentheses. That's minus 2k minus 2. And finally, my c term is my constant term at the end. That's all of this. It's 5k plus 1. So that's 5k plus 1. All right, so let's form our discriminant. Let's form b squared minus 4ac. b squared minus 4ac, therefore, will be negative 2k minus 2. That's my b, negative 2k minus 2 squared, minus 4ac is 4, a is 1, and c is 5k plus 1. And I'm going to let that equal to 0 and solve. All right, so minus 2k minus 2 squared, squaring that, square the first term, I will get 4k squared. Multiply the two terms together and double it. That will give me plus 4k times 2 is plus 8k. And then squaring the last term, negative 2 squared is positive 4. Here I have 4 times 1, so negative 4 times 1, and then so I'm just going to distribute in my negative 4 in here. I will get negative 4 times 5k is negative 20k, and negative 4 times 1 is negative 4, and that's equal to 0. Gathering up my like terms, I get 4k squared plus 8k minus 20k is minus 12k. And my 4 and my negative 4 will cancel. So my 4 and my negative 4 will cancel. And so I'm left with 4k squared minus 12k is equal to 0. So I have a quadratic in k that I need to solve. It's a quadratic binomial. In order to solve these quadratic binomials, I'm going to just factor out anything that I can factor from both terms. In this case, I notice I can factor out a k out of both terms, and I can also factor out a 4 from both terms. So factoring out 4k from both terms, I will be left with k minus 3. And that is my quadratic factored. So the solutions then are that 4k is equal to 0, and therefore k is equal to 0. That's one solution. The other solution is that k minus 3 is equal to 0, and therefore k is equal to 3. And so those are my two solutions. K is equal to 0 or k is equal to 3. Those are the two values for k that will make let it so that my function f of x has equal roots. I could just verify at least one of my results. I'll try k is equal to 0. So I know then that f of x, if k is equal to 0, will be x squared, excuse me, x squared minus x times 2k plus 2, well, that k is 0, so that will be 2 times 0, which is 0, plus 2. So that will be just 2. And then I will have plus 5k is going to be 5 times 0, which is 0, so just a plus 1 at the end. So I will have plus 1. So that is equal to x squared minus 2x plus 1. That is my function, and if I was to actually factor this, I could confirm that I do have equal roots. I have a repeating factor. If I was to factor this, the factors would be x minus 1 and x minus 1, or the x minus 1 squared. And so that verifies that k is equal to 0 is a value of k for which the function will have equal roots. I leave it to you to confirm that k is equal to 3 will also give me a value for the function that has equal roots. And so that's how, that is a little information about the nature of the roots. It is the discriminant, the b squared minus 4ac part of the quadratic formula, which tells us what the nature of the roots will be. And this is how that information then can be utilized to solve problems of this nature. All right, thanks.